So this is a bit of an update from my last video. Since then, I've done 4 more projects, so like a project per week about there. It's now week 7, so next week is finals week, and yeah, this is what I've gotten done so far. I'm mostly done with all the projects. I just need to turn this bad boy in and do the final next week. So yeah, I'll break down what each of these are next. Okay, so this is the conduit rack that I showed in a previous video. This is a refined version of it. Excuse my terrible writing. I labeled each of them so you can know which ones they are. We got electric metallic, liquid type flexible non-metallic, rigid metal conduit, and so on. So the way we're graded on this is based on craftsmanship, so how pretty the rack looks. I'm not really that great of a craftsman, but I got it done. Yeah, as you can tell, it's not all even, but it passed. This is the other half of the project, so this is a chart we're supposed to fill out, which lists all the conduit names, the letter IDs, their trade names, what material they're made of, and then certain measurements and limitations, where they can be used, where they can't be used, and so forth. And I got an A on this, so yeah, it wasn't too hard. Just takes a while to cut the conduit at first. Okay, so now we move on to the knockout punch project, which basically is making holes in sheet metal for conduit to slide in through. It's just pretty straightforward. You make your layout drawing, and then you just try to get this as close to that layout drawing as possible. Mine wasn't exact, but yeah, I passed. Oh, if you're wondering why these aren't the size of the holes that are already drawn, it's because this is more of like a guide. The actual holes, our professor said, were going to be a lot bigger. I really don't know why. He just said they were. But yeah, I passed. I got an A on this. And yeah, this is one of the easier projects I did. Yeah, there was a couple nicks, but all in all, this was pretty straightforward. And after the knockout punch came the drill and screw gauge project. So basically what this is similar to this in that we're making holes in metal. It's just the metal is a lot thicker and heavier, and we were asked to sort of file it and make it almost reflective, but I gave up because it was taking too long, so I turned it in as is. I drilled holes in. Yeah, so this was a bit more involved. So this is sort of supposed to demonstrate the different screw gauges or screw diameters. If you're a mechanic or an electrician in training, you know what these numbers mean, but basically you got your 632s, your 832s, 624s, and so on. This is smallest, biggest hole. Then we get a drill, which is, let's see if I can find it. Yeah, I got it. So we get this drill bit, drill the hole, and then we use this, which is known as a tap, and this makes let's see if I can get this to, yeah, this makes threads in the metal. So let's see if I can show it. There you go. And that's more or less the gist of it. It's supposed to get us used to making threads. Making threads onto metal. We were supposed to do the reverse of this as well, but the professor said that would have just taken too long, and it's basically the same process. So it would have just been getting a screw and then using the reverse of what this is and making threads onto the screw. So we get something similar to this, if you guys get what I mean. But yeah, once again, I passed, albeit with a bit of struggle, because as you can tell, there were some mistakes made. One of the drill bits actually broke off and I just couldn't get it out. But yeah, that's the drill and screw gauge project. Okay, so the final project of the semester is the wire chart. So this is just basically what it is, a chart with multiple different wires and sizes. I did mine from 14 to 3/0 AWG, so they can be either stranded or solid. This is just meant to show, get you familiar with wire sizes and, different types of uses. Aside from this, there is a table. Let's see if I can find it. Here we go. I haven't finished filling it out. This is not due yet. So, yeah, there you go. Conductor size, trade size, circular mills, number of strands, code letter, insulation thickness, and so on. That's a lot of electrical terms that you're gonna have to learn at some point. But what he's asking us to focus on is this circular mills, which is a way of measuring electrical wire. And this paper gives you the gist of it. So basically, the diameter of a wire is a tenth of an inch, so 0.1. So 0.1 is equal to 100 mils, and 0.2, 200 mils, 0.3, 300 mils. You get it. And so let's say you want the area of the wire. So that's calculated in circular mils. So you just do some basic math. You square the mils or the diameter. So 100 squared is 10,000, and the area of, let's say, a 0.1 diameter wire is 10,000 circular mils. And you just use that for bigger wires. Like I said, this isn't due in, I'm turning this in tomorrow. Everything's due on the final day, but just want to get ahead of time. I'm going to try to make this look a bit prettier before I turn it in tomorrow. But that's more or less how this project needs to look like. This is just some more wire. As you can see, it's a bit difficult to cut it so that it gets to this state right here. These all have to be 6 inches, by the way, with 1 inch stripped back. The smaller cables are really easy. I can do those with some regular linesman pliers. But the bigger wire, like this, which I believe is 3/0, as you can see, I gave up on this one. So what I did was I just found someone else's laying around in class, and I took it for myself. Yeah, so all of these wires weren't provided by the school. I had to go out and buy these. So I spent about, I want to say like $30-40 on all of this, because Home Depot only sells wire and by the foot, which was really annoying. And I just didn't want to buy giant spools, because this is like $4 for a foot. So you can do the math, and if I were to buy like a whole spool, it would have been run dry on cash. But yeah, that's being an electrician, at least training or whatever. Oh, and don't buy from DeWalt, they're garbage. I had to buy 2 of these sets. Well, no, not 2. I bought this one, and then I had to buy replacement drill bits because they broke really easily. It was the number 36 tap and drill bit that broke on me. So yeah, eat a dick, DeWalt.